Hello everybody, this is Mr. Parker from ParkerMaths.com, and today we're going to be looking at the OCR Core 1 paper from June 2007. If you haven't had a look at this paper yet, you can get a link to it just here. If you've already had a go and you want to check your answers quickly, you could check the mark scheme out here from OCR. So both these links are to the OCR website. If you've watched one of these videos before, you can skip the intro and go straight to question 1 here. So I would strongly recommend that you've had a go at all the questions before you have a look at the video solutions. Otherwise, you're not going to get the most out of watching this video. When the questions start, down the left there'll be links to each individual question, so you can skip ahead to the ones you want to do. If you've already had a go at the question and you think you know what you're doing, you might want to try playing the video at double speed so that you get through it a little bit quicker. Remember, you can always pause it and go back and watch bits again that you're not sure about. Feel free to ask any questions in the comments sections below. Okay, let's get started. Question 1. Simplify 2x plus 5 in a bracket squared minus x minus 3 in a bracket squared, giving your answer in the form ax squared plus bx plus c. Well, let's start by remembering that a square bracket just means multiplying it by itself. So I'm going to rewrite 2x plus 5 squared as 2x plus 5 in one bracket next to another bracket that's identical. We'll do the same thing for x minus 3 squared, so x minus 3 in a bracket multiplied by x minus 3. And this might make it easier to see how to expand these brackets. So I'm going to use FOIL to expand these, so F-O-I-L, and that means first, outer, inner, last. And that means I'm going to multiply the first terms together, so I'm going to do 2x times 2x, that gives me 4x squared. Then I'm going to do the outer, so I'm going to do 2x times 5, so that's plus 10x. And then I'm going to do the inner, so I've got 5 times 2x, so that's another 10x. And then I'm going to do the last, so 5 times 5, which gives me plus 25. So the same thing for this bracket. I'm going to write this in a big bracket to start off with though, because I'm going to take away everything that I get when I expand these. So I'm going to get x squared minus 3x minus another 3x, and then minus 3 times minus 3 gives me positive 9. There's an easier way of expanding square brackets if you know the trick, and that is if you do the first term squared, so 2x squared, I get 4x squared, square the last term, I get 25, and then notice how these two terms in the middle are the same. That's always going to be the case, so I can do 2x times the 5 and then double it, so I would get 4x squared plus 20x plus 25 minus x squared minus 6x plus 9. Now to simplify this, I have to subtract everything in this bracket. So I'm going to subtract x squared, subtract minus 6x, and subtract positive 9. That's going to have the same effect as flipping the signs of all of these things in here. So it's going to become 4x squared plus 20x plus 25. That bit's not changing yet. It's going to be minus x squared, but a minus times a minus gives me plus 6x. Minus times a positive gives me minus 9. And then all I've got to do is simplify. So I've got 4x squared minus x squared gives me 3x squared. Plus 20x plus 6x gives me plus 26x. And positive 25 minus 9 gives me plus 16. So I get 3x squared plus 26x plus 16. And we're done. Question 2, part A. On separate diagrams, sketch the graphs of, and in part 1, y equals 1 over x. So let's draw ourselves some axes. Let's draw some over here as well. And think about the shape of 1 over x. Now you should know the shape of this before you sit the exam, but if you forget it, you can still work out roughly the shape of it by thinking about certain points on it. If I think about what happens when x equals 1, well, that will become 1 over 1, which is 1. So when x is 1, y is 1. So I can think of the point 1, 1 as being on this graph. If I think about when x is really large, it's going to be 1 divided by something really large. So that will give me a really small fraction. So when x is very big, y is very small. So as x goes over here, then the value of y will be small, so it should be quite close to the x-axis down here. In a similar way, when x is very small, we'd be doing 1 divided by a very small number, which would make y very large, so it should come up here. So we're looking for a curve that goes down like that. Let's think about what happens when x is negative. Say -1, we would have 1 divided by -1, which would give us -1. So we've also got the point -1, -1 on our graph, somewhere down here. In a similar way to the shape of this one, when x is very small, that will make y very large but negative. So if x is, say, -1000, then y is going to be -1 over 1000, so very small, which means that as it goes in this direction, it's going to come close to the axis. As x gets very small, that's going to be 1 divided by a very small number, which is going to make y very large. So it's going to have the same shape as this, but flipped in the line y equals -x. So it's going to look something like this. Okay, we can label on this graph -1, -1, and also let's go over here and label 1, 1 on it. So it's important that your graph doesn't touch the axis at any point in any of these lines, and it should be very close to the axis up here, and very close to the axis here, and the same thing in the positive quadrant. Part 2, we're trying to sketch the graph y equals x to the power of 4. Well, one point we know that's on this graph is when x is 0, y is going to be 0, so we've got a point here. And it's going to be very similar in shape to x squared, but it's just going to be steeper. So we're going to have a line that comes down through here and then back up. It should look roughly symmetrical about the axes. Doesn't have to be perfect, but it should look something like this. There's no key points really apart from 0, 0 that we need to have on this. It needs to make sure that it touches the axis and doesn't go underneath. So that's all we're looking for in part 2. In part B, it says describe a transformation that transforms the curve y equals x cubed to the curve y equals 8x cubed. Okay, let's have a think about what's happening then to get us from this curve to the y equals 8x cubed curve. Each x value that we put in here is going to be 8 times larger in the new curve because we're going to cube it and then multiply it by 8. And the effect that has is that it has a stretch. And the amount that it's stretched is 8 times as much. So we say it's a stretch of scale factor 8. And it's stretching it upwards. So we would say in the y direction. So keywords we're looking out for in this question are that it's a stretch, that it has a scale factor of 8, and that it's being stretched in the y direction. Alternatively, you could put it was stretched with a scale factor of 1/8 in the x direction. But for questions like this, it's more common to say a larger scale factor in the y direction. Question 3. Simplify the following, expressing each answer in the form a root 5. So in part 1, we've got 3 root 10 multiplied by root 2. Well, as there aren't any square numbers that go into either 10 or 2, we can't simplify any of these directly. So the first thing I'm going to do is multiply these 2 square roots together. So I change this to 3 root 20. From here I can split up root 20. So I'll get 3 multiplied by root 4 multiplied by root 5. So here I was looking for a square number that went into 20. And in that case, the largest one I could find was 4. And 20 is 4 times 5, so I can split root 20 into root 4 times root 5, which is useful because root 4 is 2. So this becomes 3 times 2 times root 5. 3 times 2 is 6, so I get 6 root 5. In part 2, I've got root 500 plus root 125. Well, if I think about root 500, 100 goes into that, so I can split that up into root 100 multiplied by root 5, because 100 times 5 gives me 500. For root 125, well, the square number that goes into that is 25, so I can split that up into root 25, and I need 5 lots of that to get 125, so times root 5. Simplifying down, I know root 100 is 10, so that becomes 10 root 5. Root 25 is 5, so this becomes 5 root 5. And then I've got 10 lots of root 5 plus 5 lots of root 5. If I've got 10 lots of anything and I add another 5 lots, I get 15 lots of whatever it is, in this case root 5. So the answer here is 15 root 5. Question 4, part 1. Find the discriminant of kx squared minus 4x plus k in terms of k. We'll start by writing down the coefficients of x squared, x, and the constant on its own. So I'm going to write a equals k because that's what the x squared is being multiplied by. Our b will be negative 4 because that's what the x is being multiplied by. And the constant on its own at the end is k, so we'll say c equals k. So I'm just labelling my coefficients a, b and c like I would if I was using the quadratic formula. So we know the discriminant is b squared minus 4ac. It's the little bit in the quadratic formula that comes inside the square root. And so we're going to get minus 4 squared minus 4 lots of, well, a is k, so 4 lots of k multiplied by, well, c is also k, so k times k. This is going to give us 16 minus 4 lots of, well, k times k should be written as k squared. So 16 minus 4k squared. Part 2. The quadratic equation kx squared minus 4x plus k equals 0 has equal roots. Find the possible values of k. Equal roots means it just has one root, and that's the case where b squared minus 4ac equals 0. So let's just write that down. Equal roots implies that b squared minus 4ac equals 0. Well, we've just worked out in terms of k what b squared minus 4ac is up here. So we can now say that 16 minus 4k squared equals 0. Let's take the 4k squared over to the other side. By adding it, we get 16 equals 4k squared. Then we'll divide through by the 4. So 16 divided by 4 is 4. So k squared equals 4. So all we need to do now is square root the k. But you must remember, whenever you square root something, you get a positive answer and a negative answer. Square root of 4 is 2. So k is going to be plus or minus 2. You must remember that there's two answers for a question like this. Question 5. The diagram shows a rectangular enclosure with a wall forming one side. A rope of length 20 meters is used to form the remaining 3 sides. The width of the enclosure is x meters. Part 1 says show that the enclosed area a meter squared is given by a equals 20x minus 2x squared. Well, we've been given the answer that we're trying to achieve here, and we just need to show some working out to get it. So at the end we should know whether we've done it right. Let's have a look at the diagram up here and add some things to it. Well, if this length is x, then that must mean the other side is also x because it's a rectangle. And if you remember that the whole perimeter is 20 for this whole rope, remember we're excluding this top bit here, we can say that this length here is going to be the whole perimeter minus the 2 lots of x here. So the length of this side is 20 minus 2x. So to work out the area of this rectangle, we're going to do length times width. So the area equals x multiplied by 20 minus 2x, which gives us 20x minus 2x squared, as we require. In part B, we need to use differentiation to find the maximum value of a. Well, let's start by differentiating a. So dA by dx, that means the rate of change of a with respect to x. If we differentiate 20x, well, that's going to give us 20. And if we differentiate minus 2x squared, it's going to be negative. Multiply by the power, that gives us negative 4. And then reduce the power by 1, it becomes x to the 1 or just x. So dA dx is 20 minus 4x. We know at a maximum or a minimum, 20 minus 4x is going to be 0. This is because dA dx gives us the gradient of the original curve, and when the gradient is 0, that means the curve is going to be flat. So let's rearrange this to find x. Let's add 4x to both sides. We get 20 equals 4x. Divide through by 4, we get x equals 5. So we know at a maximum or a minimum, x is going to be 5. Now that we've got x equals 5, let's have a think about whether this will be a maximum or a minimum. So our original curve, a equals 20x minus 2x squared. If you think about the shape of this curve, let's draw a little sketch of it. Well, the only thing I'm actually interested in is the way up that the parabola is, but let's try and be accurate. We know that this is going to go through 0, so it's going to go up here like this and then come back down somewhere over here. The point up here on the turning point, you can see is going to be a maxima, because when it reaches here, it never gets any larger and it comes back down. So this would be at the point x equals 5. So we can do this without differentiating. Remember, another way that we could find out whether this is a minima or a maxima is by differentiating this again and seeing whether at the value of x we've got, that's positive or negative. But just by looking at the graph, we can see that it's a maxima. So the maximum area is going to be this equation up here, but with x equals 5 substituted in. So we get 20 multiplied by 5 minus 2 lots of 5 squared. 20 lots of 5 is 100. 2 lots of 5 squared, well, that's going to be take away 50. So we get the area that's maximum is 50 meters squared. Question 6. By using the substitution y equals x plus 2 squared, find the real roots of the equation x plus 2 in a bracket to the power 4 plus 5 lots of bracket x plus 2 squared minus 6 equals 0. So what we're going to do is substitute in y anytime we see x plus 2 squared, and what that will do is reveal a hidden quadratic that we can solve for this equation here. So if you think about x plus 2 squared and then we squared it again, we can use our power laws here. 2 times 2 is 4, so that becomes x plus 2 to the power 4. Okay, so this bracket here is going to become y squared, because it's this here squared. Then we've got 5 lots of x plus 2 squared. Well, x plus 2 squared is just y, so that becomes 5y minus 6 equals 0. Well, this is going to factorise nicely. We're looking for two numbers that multiply to give minus 6 and add to give 5. And those two numbers are 6 and minus 1. So we get y plus 6, y minus 1. That gives us two solutions, y is minus 6 or y equals 1. Now all we need to do is use these two values here to find values for x by substituting back in up here. So let's start with the minus 6, and we'll say that minus 6 equals x plus 2 squared. Problem here is if we square root this, we'd be doing the square root of minus 6, which doesn't exist in the real numbers, so we can say this one has no solution. If we do it for y equals 1, we get 1 equals x plus 2 squared. We can do this one. To get rid of the squared here, we'll square root both sides. The square root of 1 though just stays as 1, so we get 1 equals x plus 2. However, remember, when you do a square root, you need a positive and a negative answer, so it becomes plus or minus 1. All we need to do now is subtract 2 from both sides, and we get x equals plus or minus 1 minus 2. If we do the positive version, we get positive 1, take away 2, that gives us negative 1. If we do it with minus 1, we've got minus 1 minus 2, that gives us minus 3. So our two solutions are x is minus 1 and x is minus 3. Question 7, part A. Given that f of x equals x plus 3 over x, find f prime of x. So essentially this question is asking us to differentiate this function f of x, but before I do that I'm going to rewrite it in an easier form to differentiate. I'm going to leave the x as it is, but I'm going to write 3 over x as a negative power, so I'm going to write 3x to the minus 1. So then when I differentiate and get f prime x, differentiate x, that becomes 1. And to differentiate this, multiply by the power, so multiply by minus 1, that gives me negative 3, and then reduce the power by 1. Remember to follow the number line and we'd get x to the minus 2. So f prime x equals 1 minus 3x to the minus 2. You could also write this as minus 3 over x squared if you wanted as well. Part B, find the gradient of the curve y equals x to the 5 over 2 at the point where x equals 4. So we'll start by rewriting our function. We've got x to the 5 over 2. So the gradient is going to be dy dx. So if you want to find the gradient of a curve, you differentiate it. So remember the rule. Multiply by the power. That's going to give us 5 over 2x. And then reduce the power by 1. This means 5 halves. Reduce that by 1. You get 3 halves or 3 over 2. We're interested in the gradient x equals 4. So we'll say when x equals 4, dy dx is going to be 5 halves multiplied by 4 to the power of 3 over 2. Well, 4 to the power of 3 over 2 means square root it, that's what the bottom part of the fraction means, and then cube it. Square root of 4 is 2, and then 2 cubed is 8, so we get 5 over 2 times 8. And if we work that out, that's like 5 times 8 is 40, divided by 2 is going to give us 20. Question 8, part 1. Express x squared plus 8x plus 15 in the form of a square bracket which contains x plus a, and then subtract b. Before I start this, I'm just going to have a look at what happens when you expand the square bracket x plus 4. So x plus 4 in a bracket squared. That's the same as x plus 4 in one bracket multiplied by another bracket the same. And we've done this earlier in the paper. That would give us x squared plus 8x plus 16. The reason I've done that is because here we've got x squared plus 8x. So if we want to write this as a square bracket, we could start by saying that x squared plus 8x plus 15 is going to involve this square bracket here, because we've got that x squared plus 8x over here as well. So if I write x plus 4 in a bracket squared, then if I expanded this bracket out, I would get what I'm looking for, but I would also have this extra plus 16 that I don't want. So to cancel out that, I'm going to subtract 16. Then I'm going to remember the fact that I've already got a plus 15, which I can't forget about, and put that on there. All I've got to do now is simplify. So I get x plus 4 squared. And if I do minus 16 plus 15, that becomes minus 1. In part 2, it says, hence state the coordinates of the vertex of y equals x squared plus 8x plus 15. Well, this can become y equals x plus 4 squared minus 1. And you can think of this as a translation of the original curve y equals x squared. So if you think about y equals x squared, that would be a curve that goes through 0, 0. This is like saying take that curve, move it down by 1, and then move it to the left by 4. So my new curve is going to have its turning point that's related to these two here. So I could just write this down without actually doing any working out and say the coordinates of the vertex are minus 4, minus 1. Okay, you don't need to draw the graph, I've just used that to help illustrate where the answers come from. And part 3 Solve the inequality x squared plus 8x plus 15. I'm going to start by factorising this, and I'm going to look for two numbers that multiply to give 15 and add together to give 8. Those numbers are 5 and 3. So I've got x plus 5 and x plus 3 are greater than 0. Let's think about the shape of this curve. It's going to be a U-shaped parabola, and it's going to cross the axis at x equals minus 5 and minus 3. So it's going to come down here and then back up, minus 3 and minus 5. So we're interested in when this parabola is greater than 0. So let's illustrate that on the graph. So here it's greater than 0, and here it's greater than 0. We're not interested in this bit here. So the solutions to our equation are when x is less than minus 5, because minus 5 is here, look, so less than minus 5, and x is greater than minus 3, because we want this bit here. They're the only two parts where this curve is greater than 0. Question 9. The circle with equation x squared plus y squared minus 6x minus k equals 0 has radius 4. Part 1 wants us to find the centre of the circle and the value of k. What we're going to do is rewrite this circle equation in a format that allows us to easily find the centre. So first of all, I'm just going to do a little bit of rearranging of the left hand side and write it as x squared minus 6x plus y squared minus k equals 0. Because from there I'm going to use this bit and complete the square. So hopefully you can remember from an earlier question on this paper, this bracket here, the square part, will become x minus 3 squared, but that would give us an extra plus 9 if we expanded it, so we need to have minus 9 here. We've still got these other parts, so we've still got plus y squared minus k equals 0. The next thing we're going to do is take all the constant terms that don't involve x or y over to the other side. So I'm going to keep this bracket, I'm going to keep the y squared, but I'm going to add k and I'm going to add 9, so I get equals k plus 9. Now if we'd have had a term involving y and not just y squared, we would have had to complete the square for that as well, but we don't, so that stays as it is. Because when we've got the equation in this form, it tells us something about the circle. It tells us that the centre is going to be whenever this bracket equals 0, so that's when x is 3. And if we had a bracket here as well, it will be whenever that bracket equals 0, but there isn't a bracket, so it's just when y equals 0, so I get 3, 0. So with the circle equation in this format, we've got x plus or minus a number here, which tells us about the x coordinate of the centre. We'd have y plus or minus a number here, in this case it's 0, which tells us about the y coordinate of the centre. And on the right hand side we have r squared, the radius squared. So from here we can say that r squared equals k plus 9. But we already know what r squared is because we know the radius from the question. If the radius is 4, r squared will be 16. So 16 equals k plus 9. So if we subtract 9 we get k equals 7. In 9 part 2 we're told that the points capital A, which has coordinate 3, lowercase a, and capital B, which is minus 1, 0, lie on the circumference of the circle with a greater than 0. And we're asked to calculate the length of AB, giving our answer in simplified surd form. Before we get started with calculating the length of this, let's write our circle equation here with our value for k that we found in the last question. So remember, k equals 7. So we'll write our circle equation as x squared plus y squared minus 6x minus 7 equals 0. Now let's have a think about point a. We know that the coordinate is 3, lowercase a. So what we'll do is substitute that coordinate into our circle equation. So at 3, a, which is on the circumference, so we're allowed to do this, we can say we get 3 squared plus a squared, because that's x squared plus y squared, minus 6 lots of 3 minus 7, and that's going to equal 0. Let's simplify this a bit. We've got 9 plus a squared minus 18 minus 7 equals 0. If we add the 18 and the 7 to the other side and then subtract the 9, we'd get a squared equals 16, which means a is going to equal 4. It can't equal minus 4 because a has got to be greater than 0 as stated in the question. So now we know 2 points. We know that a is 3, 4, and we know that b equals minus 1, 0. So all we've got to do now is find the distance between 2 points, and we're going to do this using Pythagoras. Imagine you've got the point 3, 4 here, and you've got another point over here which is minus 1, 0, so it's going to be to the left of it and down slightly, and you want the distance between these 2 points. Let's turn it into a right angled triangle. So we'll call the length that we're looking for here L. If we want to find that length, we can use Pythagoras and say that it's going to be the distance across here squared plus the distance here squared and then square rooted. So L is going to equal a big square root of 3 minus 1 squared. So that's just the distance in the x direction along here. Doesn't matter which way round I do this. I could do this one, take this one, or I could do it the other way, as long as I'm consistent and I do the same thing for the x coordinates as I do for the y coordinates. So I've done a take away b here, which means for the other coordinate I need to do 4 take away 0. So this is going to give me the square root of 3 minus minus 1 is 4, squared is 16, plus 4 minus 0 is 4 squared, plus another 16, so this gives me root 32. Remember, I've got to give my answer in simplified surd form. The biggest square number that goes into 32 is 16, so I'll rewrite this as root 16 times root 2, because 16 times 2 gives me 32. And root 16 is 4, so I get 4 root 2. So the distance AB is 4 root 2. In 9 part 3 we need to find an equation for the line AB. Well, we've already found out what points A and B are. A is 3, 4 and B is minus 1, 0. So let's write them down. A is 3, 4, B is minus 1, 0. Now that I know what my 2 points are, to find the equation of the line AB, I first need to find the gradient, which we'll call m. So to find the gradient, you do y2 minus y1 over x2 minus x1. That means the difference between the y coordinates divided by the difference between the x coordinates. So I'm going to do it with a take b. So I'm going to take this as y2 and this is y1. So I'm going to do my y coordinates, so 4 take away 0, and divide that by 3 take away minus 1. 4 take away 0 is 4, 3 minus minus 1 is 4, 4 over 4 is 1. So my gradient is 1. So I know my equation will look something of the form y equals 1x, or just x, plus c. Let's use a point on the line next, so I'm going to use 3, 4. So when y is 4, x is 3, which makes c 1. So the equation of my line is y equals x plus 1. Question 10, part 1. Solve the equation 3x squared minus 14x minus 5 equals 0. Now, because this is a non-calculator paper, I'm expecting that this is going to factorise. If you weren't sure whether something factorises, work out the discriminant, b squared minus 4ac, and if you can square root that and not get a surd, you've got something that's going to factorise. So I'm going to look for two numbers that multiply together to give me ac. So that's 3 times minus 5, which is minus 15. I also want two numbers that are going to add together to give me b, which is minus 14. So I'm going to be looking for minus 15 and 1, because that multiplies to give minus 15 and adds to give minus 14. Now I'm going to use a little trick to help me factorise this, and I'm going to write 3x in this bracket and also 3x in this. Now this isn't going to be my final answer because 3x times 3x gives me 9x squared, and that's not what I've got. But it will cancel down. I'm going to put a minus 15 in here and a plus 1 in here because these are my numbers from up at the top. And then I'm going to cancel down any of these brackets that will cancel down. Well, this one on the right doesn't cancel. There's no common factor in 3 and 1, so that's going to be 3x plus 1. This one though, I can divide by 3 and get x minus 5. And if you check that by expanding, you'll find you get back to your original equation. So I'm going to write under here, this was just working out at the side, it's not part of my main working out. X minus 5 and 3x plus 1 equals 0. So from here I can say that my two solutions are x equals 5 or x equals minus 1/3. In part 2 it says a curve has the equation 3x squared minus 14x minus 5. Sketch the curve indicating the coordinates of all intercepts with the axes. Notice that the right hand side of this equation is the same as the left hand side of this equation up here, so I can use that factorising to help me, and I can say that y equals x minus 5 bracket 3x plus 1. So I know from above that my 2 points where it crosses the x-axis are going to be 5 and negative 1/3. I also need to know where it crosses the y-axis, and that's going to be at x equals 0. And if I put x equals 0 into this equation, this first part is 0, that's 0, I just get y equals negative 5. So I know all the points now where it crosses the axes, and that's going to be enough to draw my curve. So I'm going to label this point as minus 1/3. I'm going to label this point as 5, and down here I'm going to label as minus 5. So I've labelled all 3 points where it crosses the axis. Make sure your graph looks roughly symmetrical. Doesn't have to be perfect, but it should be a U-shaped parabola that goes through these 3 points. In question 10 part 3 we've got the same curve as before, and we are looking to find the value of c for which the line y equals 4x plus c is a tangent to the curve. Well, a tangent occurs when this line has the same gradient as this curve and it passes through a single point on the line. So the first thing we're going to do is find the gradient of this curve, and to do that we differentiate it. So we're going to find dy dx. If I differentiate 3x squared, that's going to give me 6x. If I differentiate minus 14x, that gives me minus 14. The minus 5 will disappear. So we know our gradient of the curve at any point is 6x minus 14. We are interested when the gradient of the curve is the same as the gradient of this line. And the gradient of this line is 4. It's the number next to the x, the coefficient of x. So we can now say that 4 equals 6x minus 14. So then we can add 14 to both sides and we get 6x is 18. Divide by 6 and we get x equals 3. Now that we know the x coordinate on the curve where the tangent meets, we can find the y coordinate by substituting it back into our original equation. So at x equals 3, we can say that y is 3 lots of 3 squared minus 14 lots of 3 minus 5. 3 squared is 9, times that by 3 we get 27. 14 times 3 is 42, so we're going to subtract 42 and then subtract 5. And if we do that, we get minus 20. So we now have a coordinate on the line. We've got 3 minus 20. So for the tangent, we're going to use our y equals mx plus c, and we're going to say, well, we know that y equals 4x plus c. Let's sub in our values for x and y. We get minus 20 equals 4 times 3 plus c. Subtract the 12 to the other side, we get c equals minus 32. So therefore our final curve will be y equals 4x minus 32. And we're done. Okay, that's the end of this paper. Thanks for watching. If you found it useful, think about subscribing or maybe check